Hey guys, this time we will be talking about how to ace A-level chemistry. Now, chemistry is a subject that surprisingly a lot of students have significant trouble with. Now, this is pretty surprising because compared to physics and maths, chemistry is way easier. And in spite of that, even a lot of students who rock at physics seem to have quite a bit of trouble with chemistry. Now, the reason I think that is the case is because chemistry is really heavy on the theoretical side. There is a lot of theory, there are a lot of basic fundamental concepts. And I feel that students they fail to master those fundamental concepts. Maybe they're taking it a bit too easily or they're not approaching it in the right manner. Anyhow, the result is a disappointing B. So let's see. Now, chemistry ought not be approached in the same manner you would approach physics. The practice makes perfect approach does indeed apply here to an extent, but not quite the same manner. In physics, the theory is very much easier compared to the actual questions that come up. There are some basic principles that are considered to be universal truths, and you find them easy to understand. There are three laws of Newton, and it'll take you maybe 10 minutes to memorize them, but the sort of questions that come up, they dig into the depth of various scenarios in which they apply in slightly different ways. With chemistry, it's very unlikely for the examiner to test anything but the basic fundamental things. And they don't even manipulate the concept that much. And yet students have trouble because they did not understand even the fundamental concepts. Now, how do you sort of go past this? Number one, you need the syllabus with you at all times. Number two, you either need a superb chemistry teacher, which is pretty hard to find, or you can find an easier, economically feasible way. You can turn to the YouTube, or you can turn to YouTube for help. Now, I find that chemistry is that one subject, A-level subject, that has the best teachers, or the best teachers can be found on YouTube. For the different subjects, there are indeed awesome teachers that can be found, but there tends to be just three great ones. In chemistry, there are actually 8 teachers I found to be really impressive, and I have narrowed it down to just 4 of them, whom I believe are the most helpful. There is Allery Chemistry, Irintol, McCamguy, ChemistNade, and all of these have different approaches. Not all of them are making their videos targeting CIE. However, the other boards, AQA, OCR, are oftentimes very similar in terms of syllabus content, so these work really well. Now, you can choose to approach this in whatever manner. You might just single out one teacher whom you find to be the most helpful, or you might like all of them, alternate between them in trying to find solutions to problematic concepts. Anyhow, one warning. Just don't use this, make it a manner that you just keep on, every time you have a test for a particular topic, you just go over the videos. Maybe for the next day the concepts will stick, but this whole passive learning is very destructive and very ineffective in the long term. The best way is that, say you find a video on Vespa, from, say, allergy chemistry. You turn it on, you turn all of your attention to it, you have your notebook with you, and you're actively listening to what they're saying and summarizing it on your notebook. And by the end of it, after a few hours or a few days, you can try to regurgitate the information by teaching it to a fellow or even your parents. And then you'll know how much of the concept you actually got. And if you feel that you're still lacking, you might rewatch that video or turn to some other channel for the same concept. Now, that is the first step, I believe. And the second is to turn to your main textbook. Now, this is the one that is most common, the most popular in Pakistan, and it is for the right reasons. It's superb. All of the concepts in the syllabus, and they are actually illustrated, talked about as much as they ought to be talked about. The way you can do is then you can do the topic from the book, read each line with care, think about it, write down any point that you may not have included in your initial notes, right? And then what do? After this, you will have a buttload of information from the textbook and from the teachers. Now you can do is you can sort of like attempt to make you copy all of that information down in a neater manner. Don't waste too much time on it. It just needs to be legible. And then what you can do is, by the time you've done this, probably the preliminary test would have begun. And hopefully you'll be getting in the 80s or the 90s, right? And then what you can do is, now that you've done this in the preliminary sense, you can turn to these two sites. We have Chem Guide and we have Chem Revise. Now these sites are simply amazing. I believe both of them are by chemistry teachers who are teaching at A levels. Chem Guide, and it includes almost all of the topics in a huge amount of detail, concise, a bit of extra information, but more than not, even the extra information is relevant in that they make your concepts all that much stronger. It's easy enough to navigate. We have atomic structure and bonding, for example. In bonding, you can go, and we have ionic bonding, covalent, coordinate. Let's go. And they have all of this information, and you can like read all of this, integrating all of the new points, and add it to your second notes. And you will feel that your concepts are all that stronger. And this site is particularly good for a few topics. For example, the electrochemistry topic is taught very well. And the instrumental analysis one, which is perhaps the most difficult topic in the A-level chemistry syllabus. Then there's Chem Revise, and these are these guides that are made by a chemistry teacher, and therefore like literally all of the boards. But the one you're interested in is for CIE chemistry, and these are a precious resource. They include relevant stuff, but in a lot of detail. A lot of questions. For example, if you talk about I believe the topic has to do with salts and such. It might be with chemical energetics. My apologies, it's with equilibria. And this one is actually integrating both AS equilibria content and A2 equilibria content. So it's a bit of a big file. If you're in AS, you're going to need just the upper part. There's this topic, it's really great. Like common ion effect and solubility product, they've given these examples, and they're very helpful. If you manage to master these, any sort of question that comes up in the exam will be easy for you. The most difficult part of chemistry is that sometimes there are these numericals that come up. For example, from the redox topic, from the moles topic, from the equilibrium topic, which is in A2. Now these are surprisingly and atypically harder than the rest of the paper. but they have given a lot of these examples over here. Another resource is Doc Brown Chemistry, which is most of it is at a bit of a higher level than you'd need. And even though a lot of teachers sort of like suggest that you go over it, I don't think it's a good idea, except the numerical portion. Especially about the KSP topic, which is again in A2. The questions that can come up, that can possibly come up, can be very difficult. Now there are like 7 examples they would have given over there. If you like look at them, try to solve them, you might fail at a few of them, but try and again, and your concepts on those difficult numerics will be cleared out. So that is a good side for from the numerical point of view. Anyhow, that's about it, but we ought to talk about the individual components. P1 is MCQ. It's not that difficult. Usually they're asking basic stuff, basic concepts. Sometimes they word it in a difficult manner. So for example, they'd say we have a salt, calcium hydrogen carbonate, and then in the question they'd write how many electrons are in hydrogen carbonate anion, and you might be mistaken. You might find the number of anions in total calcium hydrogen carbonate, or you may find it in hydrogen carbonate, but without accounting for the extra electron that makes it an anion. So this sort of stuff can happen. For the organic portion, there's quite a bit of stuff you need to remember. There are a lot of interconnections. So I suggest that when you're going over this, you attempt to make by yourself, from all the information you've studied, these mind maps. This is a way of doing it, right? P2 is easier, P3 is a bit difficult. Now there tends to usually be just 2 questions, or sometimes 3. And in the first question, there are 2 sorts of topics that commonly come up. There is titration and enthalpy. Now titration is something from all levels you at least know what it is. Number 1, you need to brush up on your theory on what titration is. Number 2, you're probably quite familiar with titration questions. Your mole theory should be pretty solid from all levels. If it's not, you need to be doing a lot of practice on stoichiometry, because not only do questions come up in P1 and P2, your knowledge on this topic is indispensable for P3. Now, if it's not that good, you need to practice a lot of stoichiometry. In ATP and O levels, there used to be these titration questions, so that previous knowledge ought to help you out. So the actual titration is very tricky. I'll even admit it, my titration skills were terrible. My eyesight is pretty weak, even after correction, so I had a bit of trouble identifying that exact moment when the change happened. Add to that, I hate suffocating places. And chemicals made me nauseous. I excelled at physics lab. I found it to be awesome, like learning stuff, applying your knowledge, applying all that you've learned. In biolab, it was often all right, but whenever they included something like chemicals, like stains, like HCl, stuff like that, it became hard for me. And a lot of students have problem with titration for various reasons. And oftentimes the titration question is worth say 16, and you might freak out. Now don't get me wrong, it's really important for you to master titration. You can take a look at videos on titration, on different indicators, and how to look like at the endpoint. But keep in mind, the actual titration is just about 4 marks. The thing is, it is expected of you that you should carry out a rough titer, and then you need to carry out accurate titers until you have concordant results. What that means is you have 2 results that differ just by 0.05 centimeter cube. And even if for whatever reason you were reading it all wrong, and you get an answer for the accurate titers, which are indeed concordant, but just off by 0.05, but they're completely wrong in themselves. If you write that down, if you get those results, you sort of like tabulate it in the proper manner, and the table should include the heading, initial unit reading, final reading with the units, the proper columns, the average theta value calculated appropriately. You would get a further 3 marks, right, for the tabulation part. And then if you use it appropriately in the upcoming questions and those happen to be done in a correct manner, the error will be carried forward. So in the end, you might lose just 3 to 4 marks, but you would be getting the rest of the 11 marks. And with enthalpy questions, the experimental part is actually pretty easy. But if you don't actually know why you're doing this, what you're expecting to gain from it, what that experiment actually is, you will fail at one point. Even if you carry it out correctly, when they ask you stuff like how to improve it, if we did that, the precision would increase, but how come? You will fail at it. So you should take a look at enthalpy videos about various experiments like heat of reaction, what that is, and how to sort of like use the readings you get from the experiment to get what you want. So the enthalpy chapter, which is of part of AS, is very important in and of itself and also from the practical point of view. You should have complete hold over all of the concepts. Any concept might be tested in some way. Now the second question in the practical portion has to do with qualitative analysis. You will have these unknown reactants. You will be told to add something to it and you need to note the observations and write it down, and eventually you will have to sort of like deduce what that is. Now one thing to remember is that not all of the observations that are written in the book manifest that way. You're going to have to develop a bit of street smarts. You see something and you get a bit confused. Don't write it down. Remember exactly what you saw, write with pencil somewhere. Then do all of the rest of the experiments. Eventually you will have enough knowledge to deduce that perhaps this was manganese. You're like 99% sure except for that one observation. So you just go with manganese. You alter that initial observation a bit, but don't write if it was yellowish and it ought to have been brown. Don't write brown, write yellowish brown. It could have been that the actual manifestation of this may have been written as brown, but in this case it was yellowish brown. You have to be smart about it. So you need to know all of the anion and the cations test, the gas test, and there are parts of the ACE topic that have to do with the various groups, the elements and how they react, and the observations. You have to have complete hold of it. For example, they tell us what will happen to sulfur, that you have a blue flame when it lights up. All of this can come in handy, or that phosphorus can exist in 2 different states. ChemGuide is actually very helpful about this, so you need to know this for the practical point of view. Got it? Now P5 is just ADB portion. It's pretty awesome, can be a bit unpredictable. Even for that, your theoretical understanding of the numerics and the actual way something happens the way it does ought to be 100%. And if you did all the steps I initially told you, you ought to succeed with ease. Your graphical skills should be above par. Your ability to manipulate information from graphs should be excellent. And then let's go onwards to P4, which is actually pretty easy except the last question, which is always almost from instrumental analysis. This is another part of chemistry that goes against the normal rules, meaning you need to have absolutely a huge amount of practice dealing with these types of questions. They use an alertness of mind, and above all else they need practice with similar questions so you can solve that in and not take a huge amount of time. It's by far the most time-consuming question. So I'm hoping you found this to be helpful. If you did, please like, subscribe, leave a comment, and if convenient, share this video with people whom you may think might benefit from it, or even randomly on your Facebook or whatever. Thank you.